find the average value of the function y equals 1 over x between x equals 1 and x equals 5. Use 8 rectangles and just round to 2 decimal places at the very end. All right, so let's just draw this graph. Now we know we're going to be in the first quadrant only, so I'll just draw it in the first quadrant. Now the graph of 1 over x, right, looks something like this, right? It's a rational function. We actually down here, that part doesn't matter. And then our graph goes a little something like this. Okay, I'm going to just sort of embellish this just for the purposes of the graph here, right? But essentially, okay, here's x equals 1. Here it's going to be x equals 5. Okay. We want to use 8 rectangles here, right? So now if you look at this though, right, remember, usually we use the upper sum, right? We never use the lower sum or the midpoint, right? Whenever we're finding the average value, generally we use the upper sum unless they tell us otherwise, right? So let's take a look. Here's 1, 2, 3, 4, and 5. We want to use 8 rectangles, so that means we're going to have to go in between each one here. So the first rectangle should look like this, right? The second rectangle should be here, and so on and so forth, right? Now, you got to be careful here, right? The length of each rectangle is a half. Each of these rectangles has a length or width of 1/2, right? But this is the point 3 halves, right? 1, 1.5, 2, 2.5, which is 5 halves, 3, 3.5, which is 7 halves, 4, and then 4.5, which is 9 halves, and then 5, right? So we have these 8 rectangles here. Okay? So we're going to want to find the area of each rectangle, add them all together, and in this case, divide by 4, because that is the length of this interval, right? That's what the average value is. Okay? So what is the formula here then? Well, we got 1/2 times f of 1 plus 1/2 times f of 3 halves, okay, because of this point right here, right? And then 1/2 times f of 2 plus 1/2 times f of 5 over 2. And I'll just continue down here, right? 1/2 times f of 3 plus 1/2 times f of 7 halves. Right, that's this point right here. So 7 halves is this height, and times 1/2, which is the width. And then 1/2 times f of 4 plus 1/2 times f of 7 halves. Okay? And of course, this is the function that we're using, right? All right, so what do we get? Let's plug in the 1 in here, right? Okay. So we get 1/2 times f of 1. When you plug the 1 in here, okay, that turns out pretty good, I guess. We just get 1. And then we get 1/2 times f of 3 halves, right? Let's think about that. It's 1 over 3 halves, okay, which we know is just 2/3. Okay? And then plus 1/2 times 1/2. When you plug the 2 in here, right, you get 1 over 2. Then 1/2 times, what happens when you put the 5 over 2 here? Well, that just becomes 1 over 5 over 2, which is 2/5. Okay? And then plus another 1/2 times, when you plug the 3 in here, we just get 1/3. And then same thing, right? We get 2 over 7. And then 1/2 times, when you plug the 4 in here, we get 1 over 4. And then when you plug the 7 over 2 in here, we get 2 over, or sorry, that should be a 9, right? That should be a 9 over 2. So 9 over 2, so we should get 2 over 9 in this case. Okay. All right, so we want to calculate this. 1/2 times 1 plus 1/2 times 2/3 plus 1/2 times 1/2. Do all of this, and that should give us the approximation for the area, right? Remember, this is called the upper sum because we are using the rectangles that go above the graph. Okay, so then the approximation for the area gives us about 1.83, right? Rounded to 2 decimal places. So that is the sum of all of these 8 rectangles. But to find the average, right? To find the average value, in this case, we need to take that 1.83 and just divide that by 4. Okay, so once again, round the final answer to 2 decimal places, we get about 0.46, right? And that should be the average value here.